Welcome back to another Devstream. It's been, what, 2 weeks or something like that? It's the math segment that I got stuck on. I don't know, man, it's simply too much. I started this project for the fun of it, but ever since like reaching this exercise where you had to like do some pretty advanced math, I just lost all the motivation. I tried to do another dev stream like last week, but it simply didn't happen. And I don't want to abandon the project simply because I refuse to do math. That's too pathetic even for me. So I was thinking maybe simply it's kind of like giving up, but not at the same time. I was thinking going with the like original exercise where it simply gave me the answer and I could simply copy that and then we could go through it and like understand as much as possible and then like just move on. Even if I didn't understand all the math, then it shouldn't matter too much. I mean, I should be able to simply use the functions as is, and then later, if I feel curious, then investigate them like underlying math. It's probably a healthier way to do it. Probably. It's better than simply abandoning everything, because I do want to continue, I really do. Just not with the math portion. That I'm sure of. So, with that out of the way, let's see. I just booted everything up. I haven't actually looked at where we were. Been a while, as I said, so I've forgotten about everything, I think. Not everything, but the exact details. Okay, so let's go back up to the original, I think. Where can we have it? Probably even further up. Ooh. And also this one here, remember going forward that I'm not simply copy-pasting your code but writing it myself from scratch. The end result may be identical, but this way makes me learn better. I thought this bit of context would make like the AI, I don't know, give me better instructions, but it's, in this case it made everything so much worse. So I'm probably gonna how do you say it? Addend? No. Append that statement. I'm gonna add to it. And say if we'd like more of a challenge on an exercise, then we could get it without like a pre-prepared answer and only get like vague instructions. But I do want the instructions. It's the way, or should I say the answer. It's the way I've been learning programming since forever. Like I watched a tutorial and I copied everything they did, and during the process I went through everything and made sure that I actually understood it. And then you could like take those segments and copy and paste them as you'd like and fiddle with them, and over time you'd learn like the underlying logic behind it. That's what works for me in the past, and I think I'm gonna do that with this project as well. And then maybe if like if it gets too easy, which I don't expect at all, then maybe go back to having it like this. it might be like a good idea to use the sheet or whatever you want to call it on this project, and then you could do it from scratch, or I could do it from scratch, and then only get like instructions like these, and then I could go back to this project and look through it and maybe copy and paste some stuff, write some new stuff, but not in the first pass. That would be like in a second pass of creating a language model. So, having said all that, let's see, is this the one? Yes. Okay. Where are we? We're somewhere between 15 and 16 on this scale here. I'm just gonna go back down and see. I don't know if I should reference. I can reference my own answer. I mean, I can reference like or ask about something I referenced that the chatbot provided, but I can't actually append a statement to this statement. I can edit it here, but that will probably break everything. I don't trust it. Let's see if I want to do it like this, and we go all the way down. Let's see, how do I formulate this? This isn't working out. I'd like to go back to... Wait, it was the 10th exercise, right? Exercise 10, yeah. I'd like to go back to doing exercise 10 and the following ones, like I did the previous, with clear ready-made code that I'd be able to simply copy and paste if I chose to. These vague instructions aren't enough. Please remember that going forward and only provide these vague instructions if I explicitly ask for it. This should update the memory, hopefully. This isn't working out. I'd like to go back to doing exercise 10 and the following ones like I did the previous. Maybe like I did exercise 1 through 9. With clear ready-made code that I'd be able to simply copy and paste if I chose to. These vague instructions aren't enough. Please remember that going forward and only provide these vague instructions if I explicitly ask for it as a greater challenge. Let's see what it does with this prompt. Hopefully I won't break anything, because I've been going back and forth a lot here with a lot of questions and explanations. I guess some of the information is probably stuck in my head, so it hasn't been a waste per se. Is per se a word? I think so. Thought for 30 seconds. Oh, up to the same memory, so at least Going forward, Angus wants full ready to place code for exercise like exercise 1 through 9. Do not provide spec, only vague instructions unless they explicitly ask for that as a challenge. Okay. So it looks like the AI got the memo. I'm just gonna take a very short bathroom break while this is loading in. I'll be right back. I'm back. I am back. Okay, so we should probably create the scripts simply as that. I'm also going to do the test for this one, since I want to make sure that it's actually working, as I won't have the underlying knowledge this time to troubleshoot it if something is wrong, and I'd like it to all be correct before the next exercise, because we're probably gonna reuse things we learn here. Okay. I did install NumPy and Torch, I think. Okay, so let's see here. Got it. Switch back to okay. Okay. So this one is an old one. Oh, this one is actually named the correct way as well. So it's simply, let's see. We don't actually have a main function call. We only define functions. So let's get rid of all of those, and then we're gonna import Torch and import torch.nn.functional as f. Functional. Okay. And then we have the function np logsum exp. So numpy log sum of exponential, or whatever you want to call it. We have the x, the axis that we default to an integer of -1, and keep dims for keep dimensions. We default to a bool of false, and we want to return an mp.ndarray. ndarray, I don't know what that is, but I'm not gonna be too curious right now. So and here we have stable log sum exp along axis, and still can't spell stable. And in this function then np x equals np dot as array, so we convert the x to a numpy array in case it's not already a numpy array. You see, some knowledge actually stuck with me. Some knowledge. And then we set m to np.max, x-axis equals axis, keep dims equals true, and then the y to m plus np.log, np.sum, and np.exp x minus m, and axis equals axis, keep dims equals true. Okay. And then we want to return y if keep dims equals true, else we want to return np dot squeeze y axis equals axis. So we want to return this one if we want to keep the dimensions, and if we don't want to keep the dimensions, then we're gonna squeeze it. And squeezing was something for, I think, removing the dimensions somehow, which would make sense, but let's move on. Define a function called np log softmax with the logits of an np nd array, an axis of int equals -1 or default axis, and want to return a np.nd array. So stable log soft max along axis, logits equals np.asArray, logits dtype equals np.float 64, dot float 64, and log. Why is it complaining? Undefined name. Logits equals log. I haven't misspelled it. It's the same one. See if it. Oh, okay. I'm blind. It was out of scope. LSC. I think that's how you say it. Out of scope. Log some exp. Logits axis equals axis. For the parameter axis. And want to keep things true. It's called the function that we defined here. And then we return logits minus LSC. And then we have another function called np softmax. Oh, the previous one was log softmax, okay. So this one requires the logits np.nd array, axis int equals -1. Want to return an np nd array. Stable softmax via log softmax. Return np.exp of the np log softmax logits axis equals axis. So we're basically creating a hierarchy of calls here. So we're gonna, if we call np softmax, we're gonna call np log softmax, we're gonna call np log sum exp. And then we have the function np cross entropy logits np.ndarray target equals np.ndarray, and we want to return a float. Ooh. NumPy across entropy. NumPy cross entropy, not across. Cross entropy. So mean cross entropy, and mean is average for class indices, and the classes are the choices the transformer will be able to pick from. I think. I hope I'm not simply spouting bullshit, but it should be that way, I think. Logit equals nc float like targets cn int like in 0 t. That isn't too clear to me. It's one shorter dimension, sure, but int like in 0c, no idea. Logits equals np.asArray logits d type equals np dot float 64. Then the other targets as an int 64, not a float. Wait. Targets. Almost made a whoopsie. Log probs. Logarithm probabilities, probably. And np log softmax, because we're actually calling log softmax directly with the logits and the axis of -1. And we set n to targets.shape 0. When we want to return a float of the negative log probs of the np.arange n targets dot mean. Okay, I'm feeling more and more justified in my decision to not bother with this math section at the moment. I'm feeling so justified. Okay, okay. A comment. Torch reference helpers used by tests. Oh, okay. So we have a torch log softmax of logits torch.tensor, and a new word, dim int, or new use of the word. I think tensor was explained. What was it though? Tensor. Can't remember. I'm gonna ask. What is a tensor in the when it comes to torch?
So a tensor in the context of PyTorch is basically like a multi-dimensional array or a generalization of a matrix. If you've worked with NumPy arrays before, it's kind of like that. But it comes with the added bonus that it can run on GPUs for faster computations. So it's a fundamental building block for doing all sorts of operations in deep learning.
Okay. And that's the logits we're passing around. Okay. Want to return a torch, not tensor. Return torch dot log softmax logits. Dim what? And then def torch cross entropy. And load it as a torch.tensor. Tensor. Targets. Torch.tensor. So the targets are also tensor or arrays or whatever. To return a torch.tensor. Return f cross entropy. Oh, the logits and targets. Logits. Okay. That should be the first script. Great. And then let's move on to torch warmup.py. So we need to create another. Wait, how do I? Simply here, I suppose. Call it torch warmup. Warmup.py. Is that spelled right? Yes. I can close this one again. From future. I'm a time traveler. Import annotations. From data classes. Import data class. And now import math. Import torch. And torch.nn as nn. Import torch.nn.functional. Functional as f is nn for neural network, or missed something else. I have no idea. An at data class. What does it mean to at something? Let's ask. What does it mean if I use an at data class before a class in Python?
Yeah, definitely. So when you use that data class decorator before a class in Python, it's basically a little shortcut that comes from the data classes module. It automatically adds a bunch of special methods to your class, like an initializer, a nice string representation, and some comparison methods, just by you defining the class attributes. So it kind of reduces a lot of boilerplate, makes your data holding classes really simple.
And you can do that with other types of modules or something, using an at symbol before. We should call it an at symbol even. Yeah,
so that at symbol is actually called a decorator in Python. And you can definitely use it with lots of different modules and functions, not just data classes. It's basically a way to modify or enhance the behavior of a function or a class in a reusable way. So yeah, you can kind of think of the outer as a decorator symbol, and it pops up in a lot of different contexts.
A decorator. Okay, learned something new. And I say class train results. Set that to act float. Final loss. Let's say float. And steps as an int. Okay, and then we define a function called make toy blobs. And per class as an int. Default to 200. Set the seed to an int of 0 as a default. And we want to return a tuple of torch.tensor, whatever the arrays are. Not tuple, tuple. Like that. Okay. To the Gaussian blobs, roughly centered at -2 and 0, and +2 and 0. Okay, returns x as 2 and 2, float 32, and y as 2n int 64 in 01. Not entirely sure about that one, but sure. And then we have gtorch.generator. We call, so we generate a pass along manual seed, so pass along the seed parameter, and then we have x0. Torch.random n per class to n, not m, n per class. And generator equals g plus torch.tensor. Minus 2.0 and 0.0. Okay, and this is identical, so I'm just gonna copy and paste this one, and let's see, do we have... No, it's identical, it's simply this one. It's changed to positive. X equals torch.cat. Cat of x0 and x1. Dim 0, dim for dimension, of course. And then 2 torch float 32. So this is the x-axis. And it's a bit confusing because X seems to be capitalized here, but Y isn't. I'm gonna follow along and not capitalize the Y, but it's a bit annoying to look at. Not being capitalized. torch dot zeros, n per class, b type equals torch long torch, torch ones, and n per class. This n per class is, I don't know what it's referencing. It's an integer. Maybe the amount of training? Something. Per class though is a bit confusing. Where was I? Torch ones and per class. B type equals torch dot long. Something. Ooh, this one. Okay. Comma. Beam equals 0. Comma. And then that's that. Okay. We have idx. Torch of the rand perm of x dot size 0. Generator g, and we return x of idx, y of idx. Return a tuple of two tensors or arrays. Okay, I'm not even gonna pretend to understand all of this. I understand like a vague. I have like a vague feeling on what its purpose is, but no more than that. That's one function down. Now the other function. No, another class. I mean, tiny linear of the nn.module. Did it say neural network here? Yeah, neural network modules. So NN is for neural network. At least I got that one right. And where stay linear layer 2 to 2. I'd like it to stay a linear layer, and the command is actually like on one line instead of spread out. And in the class we define init might, the self and super dot init. Okay. Self dot lin, and then dot linear 2 of 2, and the forward self x torch dot tensor. Want to return a torch dot tensor as well. Return self dot lin x. Okay. And then train another function. Train linear classifier. Epochs int equals 200, or default 200 should I say. LR float default to 0.1, not 0.1, 0.1, and seed defaults to 0. Want to return a train result. Want to return the class. Interesting. Torch.manual seed. again, and we do the seed parameter. X, Y, make void globs. And we pass along the seed parameter as seed again. Oh, and this will return the tuples. So this one becomes a tuple of tensors. And then we have the model, tiny linear. So we initialize the model as a tiny linear class. Probably. And optim sgd model dot parameters lr equals lr, final loss equals map dot inf for step in range 1 epoch plus 1. So this equals model x loss equals f dot cross entropy width y op dot zero grad set to none equals true. And we have loss dot backward and op dot step. We call this the float of the loss item. Okay. So this is somehow training it. I am very lost though. W. I wish. Thank you though. Do you have any experience with large language models or Python in general? Model X arg max. The dimension to -1 again. And active float. Rex y. Float. And the mean of float. And its item. Float. I want to return the train results. Final loss. Steps. Epochs. That should be this one done. A lot of mysteries in this one. But we'll figure it out with time. Can't be impossible to figure out. I mean, if even an AI knows what's going on, surely a human can figure it out with time. And then we want to do the tests, yes. This is probably pretty crucial to make sure that this is actually working as it should. Because even if I haven't made any mistakes, then the AI could have made a mistake somewhere. So if I go into the tests folder and create a test np torch basics. Hi. We import numpy as np. Import torch. And then from np torch basics import np softmax. NP, so all the functions we already established. Log softmax and NP cross entropy and torch log softmax. Test softmax matches torch. The testing function put RNG to numpy.random. So we do a default randomization, and we likewise set the logit to rng.normal. Is this the normalization of the numbers somehow? I'm not entirely clear on that one. See, where were we? Size equals 5. No, 5, 7. Dot as type np dot float 64. And then np sm equals np softmax. Okay, sm softmax on the logits axis equals -1. And we'll set tl to torch.from numpy. All the logits to torch.float 64. THSM softmax torch.softmax TL dim equals -1 numpy, and then we assert that np.allClose npsm.sum of the negative -1 axis 1.0 equal IE -12. And we assert that np.allClose of np.sm thsm r12 equals 1e -9 equal 1e -12. np_sm. So what are we actually doing here? We're creating a random number, we're probably normalizing that number. What does it mean to normalize something? Keep forgetting. Let's ask. What does np.normalize actually do?
So just to clarify, there's not actually a built-in np normalize function in NumPy itself. But the idea of normalizing something usually just means you're scaling an array so that it has a certain range or a certain length.
What about if you have np.random.normal?
Yeah, that one's a real function. So np.random.normal is part of NumPy, and it's used to generate numbers drawn from a normal or Gaussian distribution. In other words, it gives you random numbers that are centered around a mean and spread out according to a standard deviation that you specify. So if you want a bunch of random values that look like they come from a bell curve, that's the function you'd use.
Okay. And we want the softmax. We simply store that. We'll pass along the logits through the softmax function, store it in this variable. Wait, is this a torch? Tuple any, but it's probably tuple of torches. And TL torch from numpy logits to torch. Maybe it isn't a torch, but we're converting it to a torch here. And then THSM, so we pass the torch along through the softmax. And what does it mean to assert something? Isn't it like an if check of some sort? What does it mean to assert something in Python?
So when you assert something in Python, you're basically just putting in a sanity check that says, hey, this condition must be true at this point in the code. If it's not true, Python will raise an assertion error and basically stop execution. It's kind of a way to say, I believe this should always hold true here, and it's super useful for catching bugs early.
Okay, like I thought then. Good. And let's move to the next function. Test log softmax matches. Torch. So RNG np.random.default RNG. Ooh, 1 instead. I don't know if is this the seed of the RNG or is this something else? Well, you shouldn't hover over the 1. That won't explain anything. Because that's a simple integer. Not this one. I think I set the tooltip to too high, or maybe there are no. Oh, there are no tooltip for this one. Okay. Then let's move on to RNG normal size 3 and 4 as type np.float64. np lsm equals np log softmax logits axis -1 and tl torch from numpy all logits to what? To a torch of 64. Not 63, 64. THLSM torch log softmax. -1 dimension. Got a numpy function on that one as well. And then we assert that np.allClose, np.lsm, thlsm, thlsm, rtol, 1e minus 9, and a tol equals 1e minus 12. And then we want to test this one. Test cross entropy matches torch. So RNG equals np.random.default RNG on 2. And MC equals 6, 5. N equals 6 and C5. Logits equals RNG.normal size and C dot as type np.float64. Target equals rng.integers 0 c size n, singular n, and point false. NPCE, NP cross entropy, logits targets, and with TL equals torch from numpy logits to torch float 64 ty torch from numpy targets dot to torch dot long thce torch.nn neural network. I'm proud I got that one from context. Functional cross entropy TL.2 torch.32 ty and then dot item. No wait. The parenthesis is placed wrongly somewhere, somehow. Oh, here. Okay. There we go. And to item. And then we need to assert that MP is close, NPCE, DHCE, or toll. Toll, -6. And then to the actual testing. Create a new one. This one was in test as well, yeah. And we call this one what? Test torch 1 pi. Much simpler. And I spelled that correctly. Great. So we've to from torch warm up import train linear classifier. And then test training loop reaches ack. What's ack in this case? Could stand for acceleration or count or I don't know. Rest train linear classifier. Oh, the epoch 200 LR 0.1 and seed to default to 0, and then we assert that rest.ack is greater than or equal to 0.95, and we assert that rest.final loss is less than 0.2. Pretty arbitrary numbers for me, but let's try it out. We should also this is gonna trigger all the other tests. How can I make sure that I don't trigger all the test files when running PyTest? I don't want to run all PyTests. That will simply make everything so confusing. I'm gonna drink some tea. I have a splendid blend of Earl Grey. Very basic, but very nice. Okay, here are reliable ways to only run the test you want and keep the old ones out. Quick one of ways, no config needed. So, okay. Run a single test, node ID. Okay. Filter by name, see what would run, no execution. Ignore path just for this run. Project level fix recommended. Create or edit pytest.ini at your project root to limit the discovery. Project root, okay. So here. What pytest.ini. So we have pytest.ini and square brackets pytest. Only look for tests inside the tests folder. Test path equal tests. That's a very good one. I should have had this one from the beginning. And then we have what counts. Let's say test file class / function Python files equals test underscore apostrophe dot py. So any file that starts with test underscore and Python classes have to start with test capitalized, and Python functions test underscore, so an apostrophe have to start with test underscore and never recurs into these directories. No recurs directories, so not in .venv.git build list temp archive old and legacy. Still the question of it will still run all the test files in this case. Extra belt and suspender is optional. If you keep parked tests alongside active ones, add a small conf test py in tests. Test/conf test.py. Completely skip collecting files that match these patterns. Collect, ignore global. So we have underscore old.py, draft, legacy, archive. Then I suppose I could simply move all of these files into an archive. That might be the best solution. But would this actually work? I don't know. No idea. Let's test it out. So we got a new no, wait, no. In the root, right? No, in the tests. In the tests. Correct. Call it conf test.py. Test.py. Wait, a Fedora folder conf test.py already exists? Am I stupid? Ooh. Ooh, okay. So if I were to completely skip collecting files that match these patterns, and we have collect, ignore, globe. Set that to score old, pi, and draft. Pi, also legacy, slash, or archive. Flash. So if I were to create an archive in this one new folder, archive, and we do all of those. The archive. Yes. Move. And also test text this one to the archive. This should be the only ones. Yeah. Now we will have 2 test files here that we actually want to test, so we'll need to save this one as well. I guess this means it's gonna work, hopefully. I did the optional step and moved all the old test files into a newly created archive folder under tests. And I simply run Python and pytest q. No. This should hopefully take care of the issue, and then in the future I can simply move all the old test files into the archive. So I still get to keep them, and I'd be able to run them easily by dragging them out of the archive. It should be the most convenient solution. Yes, if you added the test conf test.py with the collect ignore global that includes archive, you can just run okay. Quick sanity check. Verify nothing from test archive is being collected. Ooh, okay. Let's see. I'm gonna type it manually. Pytest collect only you. Sure, test some info. Wait, to where? No tests collected. No module named torch. Oh, it's because I'm not inside of the venv. Is it not venv? /scripts /activate. Wait, where is it? Python. I keep forgetting, but I think that's the one. No. How do we enter the .venv virtual environment?
Right, so to hop into your .venv virtual environment, it's pretty straightforward. On Windows, you just run something like ./venv/activate in your terminal from the project directory. Once you do that, you'll see your prompt change a bit, and that means you're now working inside the virtual environment.
Okay, so maybe it was the Python part. It was the Python part. Okay, and now we should be able to do the PyTest collect only. Yeah, okay. So we have 4 tests collected. So I have test np torch basics py test soft. Make sure no file paths from test archive appear. I mean, there's no... Wait, tests... No, okay, no, there's no test/archive. But I'm a bit surprised to see 4 of them. Wait, do I only have 4 test functions? 1, 2, 3... Okay, that makes so much sense. That's why it's 4 tests. Okay. And... Okay, so now we should be able to run the Python pytest q. If anything fails, paste the exact error and I'll fix it with you. Okay, so wait. Oh. My bad. No, here we go. Let's see. 4 passed. So there was no errors. There was even a green little check mark in the corner. You can see it there. And like place myself up here to not be in the way. Okay, so this should be it for exercise 10 then. And as I said, I understand very little of the math portion. But I'm just gonna ignore it for now. I want to move on. There's nothing stopping me from going back and doing this again, and doing it like the hard way. But for now, I think I can close down the test files. Since everything says it passed, I should be free to continue. Okay. So I suppose we're moving on, which is an enormous relief. I'm gonna be honest. It's a huge relief. Huge relief. I could go through it all and dig deeper, but I'm not gonna do that. Even that, I don't think. So, I mean, if I really want to know all this, I could probably find resources online that are more concise. But I'm not going to do that. Not yet. And if I do, I'm gonna tell you. So you guys know that I failed in my goal to learn how to create a language model or AI with the use of AI. Okay, so let's see. Let's hope it also remembers that it shouldn't like complicate matters too much this time. So let's continue to exercise 11. I want to see what the next exercise entails. While it's thinking, I'm gonna take a short break. I'll be right back. Alright, I am back. So, exercise 11. Alright, Angresk. Exercise 11 is a mini character transformer. You can run on CPU. Run on CPU. It's small, readable, and comes with tests. Paste these files into your sandbox and run the tests. Tweak hyperparams later for fun. Okay. Still not gonna copy and paste it. But this looks complicated. It's a lot of code. But here we have a test, so that's not actually included in the code. Notes you can ignore, but might like later. This is a pre-norm transformer. Okay. It trains smoother on small setups. The causal mask is buffed once and sliced to current length for speed. Generate supports temperature and top K truncation for sampling control. Okay. This is a lot, but I am kind of excited still. Even though I can tell just by looking at it that it's a lot of stuff here that's going way over my head. But I think my not original, but my realization that I had recently that it's better to do than to stall and like not do anything. It's better for me to like do this and get only a portion than it is to fixate on one tiny little issue until I get bored and stop even trying. Because if I follow this, then at the end of the exercises I should still have like a functioning transformer or language model. Even though I won't know exactly how that came to be, I'll still have it. And I can go back and do it all again as many times as it takes until I finally get it, like on a fundamental level. So I haven't given up on my goal in its entirety, but I have given up on understanding everything, like from a very, very basic and ground level. It's fine if I don't understand everything, as long as it's working and as long as I'm having fun. And as much as I didn't get squat, this was fun. I like programming. But yeah, this will probably have to be it for today. I mean, there's just programming all this or writing all this gonna take probably a whole stream in itself. Why can't I? Come on. Annoying. Well, whatever. It's gonna take a while to write all of this, and I don't have that time today, unfortunately. But yeah, thank you so much for watching. I'll see you in the next one. Probably gonna stream some more The Farmer Was Replaced tomorrow, and then we'll see what's for Friday. I haven't decided yet. Maybe a new game or maybe more of the same. But I think my plan is going to be to keep these dev streams to once or twice per week. I think. More and I'll grow tired of it. But yeah, I'll see you in the next one. Cheers!